Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afi bin Muhammad. I am from S1/1 PEC. I am from Group J. Okay, today I will present about my first lab, Lab 1, Logic Gate. So firstly, I will present about Part A. So basically what Part A need is need to construct the circuit following the figure 1, okay, like this, on the multisim software. And then I need to stimulate. Okay, so I have construct the circuit on the in the multisim. So here I will use the first one, the AND logic gate. From AND logic gate. Okay, I can understand when the input input from A is higher, okay, mean 1, and low mean 0. So I will set 1 and 0 only after this. So when the power is 1 and the another source power is 0, there will be no current flow for light up the probe. When both is 1, the probe will be light up. Okay, then I will show for the OR logic gate. So when the key A is 0 and key B is 0, also the probe will not be light up. But when one of the key is higher, mean 1, the probe will be light up. Also when both is 1, the probe will be light up. Okay, then I will use the NOT logic gate. So what happened with NOT logic gate? Okay, when the power is lower, the power is low, the probe will be light up. Mean when the power is 0, okay, and then the NOT logic gate will make the probe to be light up. But when it 1, it will be 0, may not be light up. Next, I will use non-AND logic gate. So what happened with non-AND logic gate? So when my when here 0 and B also 0, the probe will be light up. But when the key is 1 and the B 0, the the probe also will be light up. But when both is 1, mean higher, the probe will not be light up. Next, I will show how the OR will be. So next, I will show about the OR logic gate. What happened? Okay, when both is 1, key A and key B is 1, the bulb will be not light up. But when both is 0, the probe will be light up. Okay, I have done with my first part A, and then I will go through part 3. So what part 3 need is I need to construct the circuit and test whether what is the result of C, E, D, F, and G. So I have construct this circuit on the multisim. So here my circuit. automatism. So firstly I will try the first one. Try the first one, the C result. Okay, so I just put my probe over here to see whether it's 1 or 0, so I can fill in this box. So okay, let me see here. When the key B is 0, the box is be light up. The probe will be light up, so it will be 1. So my C will be 1. Okay, and then I put the probe on the in front of D to find out whether it's 1 or 0. So when the key A, when the key A is 0, the bulb will be the probe will be light up. But when it's 1, mean it's higher, the result will be lower. Okay. So it will show that is when it's 0, it will be 1. And next I will find out what the result of F. Okay, once again I will try. Okay, when my key A mean the first source is 1. Okay, the key A is 1 here, and the key B is 0. When here is 0, okay, it will be light up. Okay, because 0 will be 1 here and be 1, because N is when it's high and high, it will be high. 1 1, it will be 1. Okay, so and then if the B also 1, it will be light up. Okay. Okay, and then I will try for finding the F result. Okay, so when the key A is lower, okay, and the key B is lower also, okay, it will produce a 0. Mean 0 0 will be produced 0, because the N logic gate need to be 1 and 1, not 1 and 0. So when the key B is 1 and key A is 0, the probe will be light up. But when the key A is 1 and the key B is 1, but the key A will be go through the NOT logic gate. It means 1 will be 0 here, and then 1 with 0 will produce 0. Okay, like that. Okay, and lastly, I need to try. Okay, I need to find out what the result of G. So here is G. So here I have put the probe. So again, we try. When the A is 0, okay, and the key B is 0 also, the bulb will be not light up. But when one of them is 1 and one of them is 0, it will be light up. Also, when it's both is 1, the probe will be not be light up. Okay. So I get the result like this for part 3. So like this. This is my result for part 3. Okay. Okay, I have done with my first part A, and then I will go through part 3. So what part 3 need is I need to construct the circuit and test whether what is the result of C, E, D, F, and G. So I have construct this circuit on the multism. So here my circuit on the multism. So firstly I will try the first one. Try the first one, the C result. Okay, so I just put my probe over here to see whether it's 1 or 0, so I can fill in this box. So okay, let me see here. When the key B is 0, the bulk is B layout. The probe will be layout. So it will be 1. So my C will be 1. Okay, and then I put the bulk, I put the probe on the in front of D to find out whether it's 1 or 0. So when the key A, when the key A is 0, the bulk will be the probe will be like up. But when it's 1, mean it's higher, the result will be lower. Okay. So it will show that is when it's 0, it will be 1. Okay, next I will find out what the result of F. Okay, once again I will try. Okay, when my key A mean the first source is 1. Okay, the key A is 1 here, and the key B is 0. When here is 0, okay, it will be like okay, because 0 will be 1 here and be 1, because 10 is when it's high and high, it will be high. 1 it will be 1. Okay, so and then if the B also 1, it will be like up. Okay, and then I will try for finding the F result. Okay, so when the key A is lower, okay, and the key B is lower also, okay, it will produce 0. Okay, 0 will be produced 0 because the N logic gate need to be 1 and 1, not 1 and 0. So when the key B is 1 and key A is 0, the probe will be like up. But when the key A is 1 and the key B is 1, but the key A will be go through the NOT logic gate. This means 1 it will be 0 here, and then 1 with 0 will produce 0. Okay, like that. Okay, and lastly, I need to try. Okay, I need to find out what the result of G. So here is G. So here I have put the probe. So again, we try when the A is 0, okay, and the key B is 0, so the bulk will be not like up. But when one of them is 1 and one of them is 0, it will be like up. Also, when it's both is 1, the bulk the probe will be not be like up. Okay. So I get the result like this for part 3. So like this. This is my result for part 3. Okay. Okay, lastly I will present for part 4, X0 equivalent circuit. So using existing logic gate and NOT and OR, construct below circuit in figure 3 on logic trainer and record the output of IC in the truth table. So this is the truth table, and I following this circuit and I construct on the multisim, and it become like this. Okay. So firstly I just try. Okay, so I will show the result first. So this is the result that I get. Okay, so what I need to do here is I just need to test whether whether the result is 1 or 0, low or high. So first I will place the component blue probe over here. Okay, and then I put over here for finding the C result. Okay, let's see. Okay, when the key A and key B is 0, mean lower, the C result will be higher, mean 1. Okay, and when the key A is 1 and key B is 0, the result will be lower, not the probe will not light up. Okay. And also when the key A is 1 and key B is 1, the probe will be not be light up also.
Okay, because when one used to when the both source is one mean higher, it here is not or logic non or logic gate. So when it's lower, when it's higher, it will produce the lower the low the low the low result. Okay, then I will try to find out what the result. So I put the probe here and I run. Okay, when the KA and KB is 0, okay, when lower, okay, the probe will be not light up. Okay, and A is 1 and B is 0, the probe will also not be light up. But when the KA is 1 and KB is 1, the probe will be light up because this is the AND logic gate. Okay. Okay, so let's see. We will see how the E result. So when I run, when the KA is 0 and KB is 0, it will light up the probe. When the KA is 1 and KB is 0, the probe will not be light up. But when the KA and KB is 1, the probe will be light up. Same like 0 and 0. When lower will light up the bulb. When the source is high, it will also light up the probe. Okay, here the result that I get for part 4. Okay, thank you.